Good day. Well, today's video is going to follow up from an in-class work through, primarily expanding our tools and analysis, focusing on our buffer, and then we're also going to do a KDE hotspot map. With that, I'm interested in, I have presented in front of you or displaying the unsafe vacant properties for the city of Little Rock, grabbed it from the data portal, used it a few times now. I want to make a buffer around these to see how many 2021 ag assault and homicide incidents occurred within a certain distance of these, so we can create a buffer around. Of course, we can still use select by location, but sometimes you want to do a buffer and we can display that on a map to show a bit different from that. You can see here I also have 2022, not using that because that's for their homework assignment, but could do with more recent data. With that, we're going to work in our analysis tab at the top here. If it's not your default one up here, if you click on the down arrow, it should pop up in these. If not, you can also use your toolbox itself and just search for it. But with that, we're going to input our specific feature that we're interested in making a buffer around, and that is going to be our buffer. So we want the buffer around our unsafe vacant properties. It's going to save it as a pairwise buffer. And I'm interested in a, let's say, quarter mile. And the key part with this, if we have the distance be a half mile, quarter mile, mile, whatever it is, depending on the unit of analysis you're working with and the study area and the type of feature and the expected relationship, you might be also interested in the dissolve type. If we do not dissolve here, it's going to treat each one of these vacant unsafe properties as unique. So when it creates a buffer, even if they're within close proximity, each one's going to have their own distinct buffer around. So you're going to have overlapping. This creates an issue with double counting. So when I say that, if we turn on ag assault and homicide, multiple unsafe vacant properties are within a quarter mile of each other. So they're going to be counting that same crime incident multiple times. That's when it generates an issue. To make an example, I'm going to run this with no dissolve, and I'm going to show you with a dissolve buffer. So when we create this, you can see now we have multiple circles overlaying each other. Each one's unique in that sense. If I were to open up this attribute table, we have 372 buffers. These are polygons themselves. You can clip it to the boundary of the city itself. But with that, we have ones that would end up counting the same crime multiple times. That creates an issue for what we're trying to work with. We just want to know the total amount, or say percent of total, that are within a quarter mile of unsafe vacant properties. So I'm going to turn this layer off. And now I'm going to just put a 2 after this to change it to save as a different layer. And now I'm also going to change the dissolve to dissolve all features. And I'm good with this. I am just concerned with the geographic area of a quarter mile around these unsafe vacant properties. I can click run. And now when I zoom out, you can see the difference here, and I'll turn off the crime and unsafe, that it merges or dissolves those boundaries itself. If you think about back to the tool that we use of dissolving boundaries that we went through last week, it's doing the same for you. It's dissolving the boundaries to reflect a larger area. That's all a quarter mile around unsafe vacant property. So if I layered that back on, that's the area it represents. Again, if I turn this layer off and the original one on when there's no dissolve, these are multiple buffers that overlap each other. That's what we're getting rid of itself and creating a larger area to work with, which is more reflective of what we're trying to capture. So now if I was interested in how many ag assaults or homicides occur within a quarter mile of an unsafe vacant property, have this layer, and I can do a map, go to map, select by location. And I'm interested in our 2021. That's within the buffer layer that we just selected or created. That's the second one. Click apply, and you can see down here I have 1,735, or if I were to open this attribute table, I get the same number down here. So 1,700. So if I want to create this a percent of total, I can go ahead and then do 1,735 divided by 3,429. So about 51% of all ag assault and homicide for 2021 occurred within a quarter mile of an unsafe vacant property. Quite a bit there, especially if we look at the overall area of Little Rock being covered in this. We could develop a location quotient to identify if it's unequally distributed. And we can see that visually, eye level, I say that. There are clusters, and that's what we're going to do next is, can we generate hotspots from the same data? So right now, when we just eyeball it, we can see areas that are more dense than others, but there's a way to visualize this and run this into a hotspot analysis. We use this a lot within crime analysis. A lot of police departments have used this for decades now, of multiple techniques of using it or trying to generate a hotspot. We're going to go over a common one known as Kernel Density Estimation, KDE, on generating a hotspot. With that, we're going to go back into our analysis tab. It's still an option within here. Later, outside of the semester, I'll work specifically in this crime analysis extension or toolbar that they put a lot of this in the same area. Really cool stuff. But for KDE, we're still working within our analysis. Come down to kernel density, and it's asking you to input. What do you want to make a density raster of? For our purposes, that's the 2021 ArcGIS on homicide. We're not worried about the population field at this point. Each one's individual, no weighting or anything to that, no population base. Would be cool to work in some of the ambient population data. Future's not. We're going to keep the output raster as the same. Keep in mind this one is specific to how many characters are in the file name. So if you ever see that red X, it's oftentimes you just need to change how many characters or letters, numbers are in it. Default, I'm going to keep for now. Output cell size, this is the default that they choose. Knowing Little Rock, the average street segment's more around 430 to 40 square feet, or feet itself, sorry. For our purposes, I'm just going to round this up to 500, knowing Little Rock itself. Pretty common within the literature to use 500. To each their own. I like to cater or tailor more to the city itself. Area units, I'm fine with keeping it for square miles and densities for now. So truly keeping some of the default settings just to get you in the habit of creating your first iteration of a hotspot map. With that, the key part to this is the environments tab. At this point in the semester, we haven't used this one at all. If you look at our crime points within Little Rock, if we look at north, south, east, west, it doesn't capture the most northern point or southern or eastern and western. So that can create an issue. If we were to run it now, it's only going to base our study area on the point itself versus the Little Rock city boundary. So to change that, I'm going to hop over to our environments tab. Our processing extent is no longer going to be default. We're going to set it to our Little Rock boundary, which now gives us those north, south, east, west points for us. Hop back. I can click run here, and it's going to generate a hotspot map for us, a density map. And this is where, from a symbology standpoint, you can go in and change what you're working with here. So I'm going to turn off our crime layer, and you can see now it's generated in the purple values here. And you can see our density values within it. So not shockingly, if you ever see a hotspot map, and I'll go into my symbology, and I'll change it to that's equal interval and it's across 10. I'm going to change the color scheme to be more reflective of what oftentimes we see is the red being more intense. So it's a hotspot itself. And you see this, oh shit, now everything's green. You can change the bottom one if you click on it to no color. And now you can see within here what that hotspot looks like. You can also change it based on what you're trying to display with it. So you can still change it based on a lot of these other symbologies methods to it. We can get into this based on standard deviations on what this looks like as well. Keep in mind, you have the ability to generate different types of map depending on what you're working with within GIS and what the overarching purpose is. You can still change the labels within here. So you do have the ability to manipulate how it's being displayed to identify what is hot and what's not. But at this point, you can get a good example of how to generate a hotspot map. If you look at our points, then kind of go back and forth, and we'll learn how to do the swipe screen and everything with that. It's not a bad way to see how this is generated. So oftentimes you can take this map and create a final map from this, or a final product that reflects a hotspot map of Little Rock. I can change this to 10, update that a little bit. There we go. But with that, two quick examples of one, how to create a buffer, and then how to create your first hotspot map without getting into too technical or parameter selection details. But this is to get you familiar with the process, and there's always more articles, books, readings out there on the technical side of the parameter selection and generating what is a hotspot. If there's any questions, as always, feel free to reach out. Take care.